Welcome students. In this video I will be taking up the topic of coordinate geometry. This video is in continuation to my previous video on coordinate geometry. Let's recapitulate what we all did as far the previous video is concerned. If you remember and if you have watched my previous video, we discussed all about distance formula. We discussed how we could find distance between 2 points whose coordinates are given, and how this concept of how this concept of distance formula could be applied to different situations. Like you have a triangle whose vertices are given, and you are asked to find out that if this particular triangle whose 3 vertices are given, if it's a scalene triangle, a right angle triangle, isosceles triangle, or an equilateral triangle. Then we extended this to a polygon, a 4-sided figure whose 4 vertices are given. And using distance formula, we could find out that if that particular quadrilateral is a rectangle, if it's a square, a rhombus, or a trapezium. Now, as for this today's video is concerned, we'll be taking up the second topic of coordinate geometry, that is section formula. Let's see what all we have to do in section formula. So the word starts with section. So this formula, section formula, is all about section. Let's see what we mean by section, the word section. If I take a line segment AB, and this is my line segment AB, obviously coordinates of A and coordinates of B will be given. Now AB is a line segment, it's nothing but collection of points. There are so many points between A and B, infinite points. If any point is taken, let me take that point as C. Now this C can be midpoint also, not necessary. So I have a point C. Now coordinates of A I take as x1, y1, coordinates of B as x2, y2. Now, when you choose a point between a line segment AB, we say that this line segment got divided into 2 parts. Like one part is AC, other part is CB. Now, AC and CB both are 2 parts. Or together we say AB and CB, they are both sections. In fact, they are segments also. AC is also a line segment, CB is also a line segment. But we could make use of the word section. So AC is one section and CB is the other section. As for this figure is concerned, this AC section is smaller than CB section because C is closer to A than to B. Now, if C is the midpoint of AB, then AC and CB are 2 sections which are equal. AC will be equal to CB. In that case, C will be the midpoint. Now, what all will be given and what all you have to find? Now, coordinates of A will be given, coordinates of B are given, and C is dividing AB in a certain ratio. That ratio will be given. And don't forget that we say C divides AB internally. C divides AB internally. C can divide AB externally also. That is grade 11 concept. Now, let the ratio be M is to N. We could take the ratio as M is to N. Some books take it as M1 is to M2. That means AC is M units and CB is N units. So M and N, they are both positive integers, like 2 is to 3, 1 is to 5, and so on. So coordinates of A are given to you. I put a tick for A. Coordinates of B are given to you. The ratio M is to N is also given to you. And you are asked to find coordinates of C. So I suppose that coordinates of C are x, y. So I have to find coordinates of C provided coordinates of A, coordinates of B, and the ratio is given. So this is missing for me. So in such a situation, I will make use of section formula. So in short, section formula is a formula that helps you to find the coordinates of a point of division which divides the join of A and B in a certain ratio. Coordinates of A to be given, coordinates of B to be given, the ratio should be given, so then you could find coordinates of C. Let's see what's the formula all about. Now, I say let C divides AB in the ratio M is to N. Now this x coordinate, the formula says x will be, x coordinate of C is M into x2. M into x2 plus N into x1. N into x1 divided by M plus N. This is the x coordinate of C, and C is the point of internal division dividing in a certain ratio. Just remember it. You are taking the product of the M, which is the first component of the ratio, M is to N, multiply it with the x coordinate of point B, mx2 plus nx1 divided by M plus N. And on the same lines, y should be my2 plus ny1 divided by m plus n. So using this formula, you could find coordinates of C. Now, is it important for us to derive this formula as for examination CBSE is concerned? Usually, this is not from examination point of view. If you have a look at the textbook, your NCERT textbook, derivation is there. He's making use of similarity of two triangles and deriving this formula. Now, what are the different situations in which we can make use of this formula? Is this the only situation in which you can use this formula? So I would say no, this is not the only situation in which you could use the formula. What are the other situations in which this formula could be used? Now this formula could be used if out of these four parameters, see 1, 2, 3, 4, coordinates of A, coordinates of B, coordinates of C to be found provided the ratio is given. Now other situation would be if, for example, C is given to you, ratio is also given to me, coordinates of B are given, so I have to find coordinates of A. In such a situation, you will use the same formula. So out of four components, out of four parameters, 3 should be given. We could find the fourth one. That means we could say that if coordinates of B are now missing, so coordinates of A should be given, the ratio should be given, and coordinates of C. Don't forget, you have 3 points, A, B, and C, and one ratio. Now, these are 3 situations in which coordinates of A to be found, rest given, coordinates of B to be found, rest given, coordinates of C to be found, rest given. And the fourth situation will be in which A coordinates B and C are given, and you have to find a ratio. There also we use the same situation, so coordinates, same formula, coordinates of A given, coordinates of B given, coordinates of C, and we have to find the ratio. So we will use this formula in 4 contexts, 4 situations. But out of 4, 3 have to be given. They should be given. Now we have exercise 7.2, page 167 of your NCERT textbook. So we have 10 sums as far as this formula is concerned. Let's try to see how many sums we are able to attempt as far as this video is concerned. I will be taking the first question of exercise 7.2. So I should be writing section formula exercise 7.2, and I'm writing the formula which we are going to use. That will be written just here. This is my AB. If I take coordinates of A as x1, y1, coordinates of B as x2, y2, coordinates of C, you assume it to be x, y, and the ratio is m units is to n units. So you write the section formula as x is mx2 plus nx1 divided by m plus n. Just keep on writing this formula whenever you use a particular question in which this formula is to be applied. Just write this formula so that things get organized in your mind. my2 plus ny1 divided by m plus n. So let's take the first question. First question of exercise 7.2 of your NCERT textbook. It says find the coordinates of the point which divides the join of -1, 7, that's my point A, 4, -3, that's my point B, and the ratio 2 is to 3. So -1, 7 and 4, -3. -1, 7, this is point A, point B is 4, -3. 4, -3, and the ratio is 2 is to 3. That means C is nearer to A. 2 is to 3. This is 2 units and this is 3 units. So I have to find coordinates of C. So we say let C x, y, let C x, y divide AB in the ratio 2 is to 3. Right? So using section formula, or you could say applying section formula, both are correct. Using section formula, we have, just write the formula. Formula is x is mx2 plus nx1 divided by m plus n. Now what is m in this case? It's 2. You could see this is m, this is n. This is x1, this is y1, x2, y2. For x1, y1, go to vertex A. For x2, y2 go to vertex B, and for xy go to vertex C. It's not vertex, sorry, it's point. Okay. mx2, x2 is 4 plus n is 3 into x1. x1 is minus 1. This is our formula. So we will isolate it this way. The formula we are using. Okay. Divided by m plus n, that's 2 plus 3. So on simplifying, x will be 8 minus 3 upon 5. That's 5 upon 5, so that is simply 1. Let's find y. So I should start from this place. Y is equal to my2 plus ny1 divided by m plus n. What's my m? That's 2. What's y2? y2 will be minus 3. Plus n is 3 into y1, that's 7 upon m plus n, 2 plus 3. That's minus 6 plus 21 upon 5. Minus 6 plus 21. 21 minus 6 will be 15 upon 5, so that is 3. So therefore, coordinates of C are 1, 3. See, x is 1, y is 3. So that this way we have found the coordinates of C when the rest of the things were given. So this was question number 1. Now we have question 2. Again, finding points of coordinates, more than 1. In question number 2, see what you have. You have again a line segment AB whose coordinates are given. Now there's no ratio given. Then what instead of ratio, it's mentioned, find the coordinates of the points of trisection. Find the coordinates of the points of trisection. And on the same lines, you have question number 9. I would like to do these two sums together. See, read question 9. He says, find the coordinates of the points which divide the line segment A and B into 4 equal parts. So let's analyze what's given. So I have a line segment given as per question 2 is concerned. In that line segment, you have to find coordinates of those points that divide this line segment into 3 equal parts. So I have to find coordinates of the points of trisection. Means 3, trisection, 3 equal parts. So that means you will have 2 points which will divide a line segment into 3 equal parts. Let's take it in a broader prospect. See, if I have a line segment AB and there's a point which happens to be the midpoint. If AB is a line segment and C is a point, that divides it into 2 equal halves. So in this case, C is the point of bisection. This is nothing but point of bisection. Bisection. Bi means 2, section, parts, 2 parts. But parts have to be equal, 2 equal parts. So one point divides a line segment into 2 equal parts. So C is the point of bisection, which is also known as midpoint. Now again I take a line segment AB and I divide it into 3 equal parts. So 2 points will divide it into 3 equal parts. This part, this part, this part. They're all equal. So 2 points will divide a line segment into 3 parts. That means number of points is 1 less than number of parts. If I have n points, so how many parts I will have? N plus 1. It's common. So one point will divide into 2 parts and 2 points will divide into 3 parts. So if I have 1 point, then you have 2 parts. If you have 2 points, you have 3 parts. If you have 3 points, then you have 4 parts. Now C and D are points of trisection. They divide it into 3 equal parts. And if you divide a line segment into 4 parts, that means this is my C, this is my D, this is my E. Now AB is divided into 4 equal parts. Now how many points? 3 points. So you could say they are points of, you could say use the word quadrisection. Like quad means quad is 4, or tetrasection, I think that's a better word. So this is bisection, this is trisection, this is tetra, divided into 4. So 3 parts will divide into 4, 3 points divide into 4 parts, 2 points divide into 3, and so on. Now this is your question number 2, this is your question number 9. We'll do it together. And for point of bisection, you'll use the same formula. In fact, all same formula to be used for all sums, as I said that in the beginning. Now coordinates are 4, -1 and -2, -3. So that's our question number 2. 4, -1, 4, -1 and -2, -3. This is A and this is B. This is question number 2. And what you are asked to find the points of trisection. That means let C be one point and D be the other point. So 1, 2 and 3. So we say let C and D be the points of trisection for line segment AB. Now you have to find C as well as D. We can't find them together. We'll find them one by one. Let's focus on C. So let me take coordinates of C as x comma y. So we say C, whose coordinates are x comma y, C divides AB in the ratio. Now in what ratio C is dividing AB? Forget D for the time being. C is dividing AB in the ratio 1:2 because this is 1, 1, 1. So if you say this up to this one part and two part, so it divides in the ratio 1:2. C is dividing AB in the ratio 1:2. So what you do, you apply section formula. I think you can do it because this is 1 unit, these are 2 units, this is your M, this is your N, this is X1, Y1 and so on. That means X will be mx2 plus nx1 divided by m plus n. M is 1 into x2 is -2 plus n is 2 into x1 is 4 whole upon m plus n. So on simplification, this is -2 plus 8 upon 3. 8 minus 2 is 6 upon 3, that is 2. So coordinates of x are, means value of x is 2. Now what about y? It's my2 plus ny1 divided by m plus n. Again, m is 1 into y2 is -3 plus n is 2 into y1 is -1 whole upon 1 plus 2. That's -3 minus 2 upon 3. That's -5 upon 3. Keep it in the P by Q format. No need to divide it. That means you found coordinates of C as 2, comma, -5 upon 3. So C is -2, comma, -5 upon 3. So you found coordinates of C. Now we are asked to find coordinates of D. If you apply the same logic, coordinates of D, if you have a look at D, now D is dividing AB in the ratio 2:1. As C divides in the ratio 1:2, D divides AB in the ratio 2:1. That's one way. The other way is, if you observe, D is the midpoint of CB. D is the midpoint of CB. So you could use the midpoint formula. Now, how come this midpoint formula came into existence? We discussed section formula. Now, what is midpoint formula? See, midpoint formula is an extension of section formula, provided the point of division is the midpoint. That means in which the ratio is 1:1. M and N are same. C is the midpoint. M is to N reduces to M is to M, or N is to N. In short, it reduces to 1:1. Now, is section formula and midpoint formula different? No, they are not different. If in section formula M is equal to N, it reduces to the midpoint formula. Otherwise, you could apply section formula once more for finding coordinates of D, taking the ratio as 2:1. Or if D is the midpoint of CB, there also ratio is 1:1. But I would like you to remember this midpoint formula. That way, it's quite easy to solve sums based on midpoint formula. See, I'll be applying midpoint formula to D. Now, we'll apply the midpoint formula to find coordinates of D. Now, see, let D, you could again take xy, d, xy fact, why should you write let? Obviously, dx comma y is dividing, d divides CB in the ratio 1:1, right? Now, x will be, when you apply the same formula, you will have m into x2 plus n into x1. We forgot the coordinates of C. Where were the coordinates of C? We forgot that. Okay, let's take d divides AB. D divides AB in the ratio 2:1. We'll take that. I missed out the coordinates of C. Okay, D is dividing AB in the ratio 2:1. Now, coordinates of D are, this is your x, this is your y, m into x2 plus n into x1. I'm still relying on A and B. I thought I will take D as the midpoint, but we have not recorded the coordinates of C. Okay, we'll do it this way. This is the beauty of maths. You could do a question in more than one way. Now, x is m x2 plus n x1 divided by m plus n. M is your 2. This is your 1. Right? M x2 plus n x1 divided by m plus n. So this is nothing but minus 4 plus 4 upon 3, that is 0 upon 3, that's 0. So x is 0. Now what about y? Y is m y2, m into y2. This is y2 plus n into y1 upon m plus n. That's minus 6 minus 1 upon 3, so that means minus 7 upon 3. So coordinates of D are 0, comma, minus 7 upon 3. Now, let's see what that midpoint formula was, which I was just discussing, and how we'll use it. Now, I have a line segment AB. This is my A. Coordinates are x1, comma, y1. B are x2, comma, y2. And C is the point of division, which divides it internally in the ratio 1:1. So C is the midpoint. So this is 1 unit, this is 1 unit, means 3:3, which reduces to 1:1. So let coordinates of C be x, comma, y. Now when you apply the section formula, you say x equal to m into x2 plus n into x1 divided by m plus n, which simply sums up to x2 plus x1 upon 2, which could be rewritten as x1 plus x2 upon 2. Now what is x? X is the x coordinate of the midpoint. And what is that? It's simply the mean of the x coordinates of the endpoints. Doesn't this mean x1 plus x2 by 2? In other way, you would say the x coordinate of the midpoint is the sum of the x coordinates of the endpoints divided by 2. This way you could remember that, so the x coordinate of the midpoint is the sum of the x coordinates of the endpoints. So x is x1 plus x2 by 2. Similarly, the y coordinate of the midpoint is the sum of the y coordinates of the endpoints. That means y is equal to y1 plus y2 upon 2, which is also as the y coordinate of the midpoint is the mean of the y coordinates of the endpoints. X coordinate is the mean. If you say mean, or otherwise you would say sum of the x coordinates of the endpoints. So we could have used this for question 2. Now question 9 you could do on the same lines, because you have to find points which divide a line segment into 4 equal parts. So that means there are 3 points. Now we proceed further. This is question number 3, and the diagram is shown. Basically, this is regarding sports day. They say regarding sports day, to conduct sports day activities in your rectangular shaped school ground ABCD. So there's a diagram, you have ABCD. If you have a look at your textbooks, ABCD is the rectangular field, school ground. Now lines have been drawn with chalk powder at a distance of 1 centimeter each. Now you could say there are rows and columns. Along rows you have 10 divisions along AB, and along AD there are flower pots placed which are 1 centimeters apart. Okay, chalk powder at a distance of 1 meter, not 1 centimeter, 1 meter. 100 flower pots have been placed at a distance of 1 meter from each along AD. So along AD, that is your y-axis. AD is your y-axis and AB is your x-axis. Now along x-axis, which is your AB, you have 10 divisions at a distance of 1 meter each. And along AD, you have 100 flower pots at a distance of 1 meter each. Okay. Now this is figure 7.12. Now Niharika runs 1/4 the distance AD on the second line and posts a green flag. Niharika, maybe she's the head girl, she posts a green flag, but running on the second line and covering a distance of 1/4 of AD. How much is AD? AD is 100 units, 100 meters. Because along AD, 100 flower pots have been placed at a distance of 1 meter each. Now we need to find coordinates of Niharika. Let's take Niharika by letter N. Then there's Preet, who runs 1/5 of the distance, and so on. Let's first prepare the coordinates of these points. So this is my question number 3. Let me take N. What are the coordinates of N? Now, what's the run? If you remember for coordinate geometry, we said run and rise. How much you traveled along x-axis, that will be your x-coordinate. How much you traveled along the y-axis. Now, the Niharika is going in the second line. That means its x-coordinate will be 2. And how much along AD? 1/4 of the distance AD. AD is 100. 1/4 of 100 is 25. So coordinates of N are 2, 25. Then Preet runs 1/5 of the distance AD on the 8th line. So 8th line Preet, that means x coordinate will be 8. How much? 1/5. 1/5 of 100, that is 20. So you got coordinates of P. Okay, let's join N with P. This is my P. So they are posting flags here. Preet is also posting. Niharika has posted a green flag, and Preet has posted, maybe Preet is the head boy, he has posted the red flag. Now what is the distance between both these flags? It's a case of distance formula. What's the distance between N and P, or P or N? Use distance formula. This we have already discussed. It's your cup of tea now. Now, if Rashmi has to post a blue flag exactly halfway between the line segment joining the two flags, Rashmi, maybe she is a wise head girl, Rashmi has to post a flag somewhere in between Niharika and Preet. If that's the case, where should she post her flag? That means you have to find coordinates of R. Now let the coordinates of R be x comma y. And what is the ratio? It's 1:1, because she has to post a flag somewhat in between the flags posted by Niharika and Preet. That means you have to find the coordinates of R. It's a case of midpoint formula. So let R x comma y divide NP in the ratio 1:1. So what would you do? So you will simply apply using midpoint formula, just now which we prepared, using midpoint formula. So midpoint formula will tell you that x equal to sum of the x coordinates of the endpoints upon 2. That means x1 is 2, plus this is 8 upon 1 plus 1. That means 10 upon 2. That means 5. And what about y? y1 plus y2 upon 2. So y1 is 25 plus 20 upon 2. That means 45 upon 2. That means 22.5. So that means this Rashmi has coordinates 5, 22.5. So Rashmi has to post a flag she has to walk in the 5th line and traveling a distance of 22.5 meters along AD. So which line she has to walk? She has to walk in the 5th line and at a distance of 22.5 units along AD. Okay, this was a case of midpoint formula. Now, if you remember in the beginning, I said we will be using this formula in different situations in which out of these 4 parameters, coordinates of A, coordinates of B, coordinates of C, and the ratio out of 4, any 3 are given, and we have to find the 4th one. Question 4th is a case in which you have to find the ratio. That means A, B, and C are given. Now let me see how I will do it. I will do it using the same formula, but most of the books do it using the ratio 1:k or k:1. Now we will resort to the same formula. Find the ratio in which the line segment joining -3, 10, -3, 10, this is my A, and what is my B? 6, -8, 6, -8, this is my B. It's being divided by a point C whose coordinates are -1, 6, this is point C. What's the ratio? We don't know the exact location of C, randomly you put C. So what the ratio is, I will take the ratio as m:n. So we'll say let C -1, 6. Let's cross check coordinates we have taken correct. Yeah, -1, 6. Let C -1, 6 divide AB in the ratio m:n. Now what you do, using section formula, apply section formula. That means x will be mx2 plus nx1 divided by m plus n. Let's work on this. Maybe we don't need to prepare the y coordinate. How much is x, my dear friends? X is -1. This is your x. See, this is x1, this is y1, this is x2, this is your y2, this is x, and this is y. This is m and n. Okay. X is -1 equal to m is m, x2 is 6, plus n is n, which I have to find, and x1 is -3 whole upon m plus n. Now do the cross multiplication. This will be -1 times m plus n. This is 6m minus 3n. Further simplification, -m minus m minus n is equal to 6m minus 3n. So if we segregate m to one side and n to the other side, so this would be -m minus n. Let me take 6m to the left. It's minus 6m equal to minus 3n. Okay? So that would be minus 7m equal to minus 3n plus n. I shifted this to the right. So minus 7m equal to minus 2n. Multiplying both sides by -1, so 7m equal to 2n. Or m by n is nothing but 2 upon 7. So that is the ratio. 2 is to 7. So m by n is 2 is to 7. So using the same formula, we have found the coordinates. We have found the ratio, provided the coordinates of the points of division were given. Okay. Let's move on to the next sum. That's question number 5. Here again you have to find the ratio and you have to find the coordinates of the point of division. Two things to be found. Find the ratio as well as find the points of the coordinates of the points of division. After that, we have a very beautiful sum which is based on a parallelogram. So we'll move on to the next sum. So we have finished question number 4. As for the next sum, question 5 is concerned, this is also on the same lines. A line segment is given and there's a point of division whose coordinates are given. In fact, its x coordinate is given because the point of division is on the x-axis. So its coordinates will be x, 0. And what you are asked to find, you are asked to find the ratio. So you apply the same logic as we did for question number 4. So just do remember, so out of 4 situations, out of 4 parameters, 3 are given. We need to find the 4th one. Now, we'll apply same formula, the section or the midpoint formula, to question number 6. Now in this case we have a parallelogram whose vertices are given, but in this case some of the vertices are to be found, means for a particular vertex maybe x coordinate is to be found or y is to be found. Now ABCD is a parallelogram whose vertices are, let me take this as A, this is B, this is C, and this is D. Coordinates of A are given to be 1, 2. Coordinates of B are to be given as 4 comma y. Now y to be found. Now coordinates of C are x comma 6. And what about D? Coordinates of D are 3 comma 5. So a parallelogram ABCD in which coordinates of A as well as D both are given, but you need to find the y coordinate of the vertex B and the x coordinate of vertex C. Now how we do that? Okay, this is my question 6. You are asked to find x as well as y. What is x and what is y? So since it's a parallelogram, we know opposite sides are equal. So what else? We know the diagonals of a parallelogram bisect. So we'll be taking that concept. So BD is one diagonal and AC is the other diagonal, and they intersect at a point. Let me take that point as O. So AC diagonal and BD diagonal, they bisect. Diagonals of a parallelogram, they bisect at O. What does that mean? That means O is seated on AC as well as BD. O is the midpoint of AC as well as BD. Let me take it one by one. So this is my question number 6. So I say O x comma y, it divides AC. What's the ratio? It divides in the ratio 1:1 because it is the midpoint of AC. So what are coordinates of O? Just now we said the x coordinate of the midpoint is sum of the x coordinate of the endpoints. So I would say O is x1 plus x2 upon 2, comma y1 plus y2 upon 2. So this you are taking O on AC. So O will be, now focus on AC. What's x1? It's 1, x1 plus x2 upon 2, comma y1 plus y2 upon 2. That means coordinates of O are 1 plus x upon 2 and 6 plus 2, 8, 8 by 2, that is 4. So this way you have prepared coordinates of O when you have taken the diagonal AC. Now take diagonal BD. This was for AC, diagonal AC. Now take diagonal BD. Now for BD, prepare coordinates of O on the same lines. Now O is on BD and O happens to be the midpoint. Now if I apply it directly, this will be x1 plus x2 upon 2, comma y1 plus y2 upon 2. That means O is 7 upon 2, comma y plus 5 upon 2. So you have coordinates of O 1 plus x upon 2, comma 4, and you have again coordinates of O as 7 upon 2, comma y plus 5 upon 2. But since O is the common point, is the same point, it's on AC as well as BD, so we compare coordinates of O, x as well as y. So when we compare, let's see what we get. So you could call this equation as 1 and call this equation as 2. So we conclude from 1 and 2, x coordinate of O here and x coordinate of O here, they are same. So that means 1 plus x upon 2 is nothing but 7 upon 2. That means 1 plus x is 7, that means x equal to 6. So we got the x value. And similarly, 4 is equal to y plus 5 upon 2 is equal to 4. That means y plus 5 is equal to 8. That gives you y equal to 3. So these are the values of x and y. So that way we have found the coordinates of the y coordinate of B and the x coordinate of C. Now there are other sums which are, in fact, I believe they are on the same line. So I would recommend you just give a try to these sums, and I hope that you are able to solve these sums up to question number 10, taking help. Except question 10, my dear friends, this question 10 is based on area of a rhombus. So leave this question 10. We'll tackle this question 10 once we do the third topic, that is the area formula. Okay, so this brings me to the end of this video. I hope you will be benefited after watching this video. So till next video, all the best. Happy learning. Thank you.